Bismillahirrahmanirrahim. And high voltage technology. And today I will demonstrate few of the experiments. Although we don't have the lab in the high voltage technology course, but I wish to show you some video clips which I have downloaded from the YouTube and merged 4 different videos so that I can show you uh, how the breakdown actually occurs. So first we will start with the gaseous breakdown. We will use the plate electrodes for the gaseous breakdown. And I have already told you in the lecture that using plate electrodes we cannot achieve the uniform field. But there are a few conditions for the plate electrodes to approximately achieve the uniform field. So the one condition is that the length of the electrodes should be as lengthy as possible. So theoretically it should be infinity. At infinity length of the plate cannot be achievable, but it means that as lengthy the electrodes are, the field will be uniform that much. Okay. And second is the separation between the electrodes. As closer as the electrodes will be, so the field will be uniform. But it doesn't mean that you can touch the electrodes, because if you touch the electrodes, there will be no gaseous particles between the electrodes. So how the breakdown of the gaseous will be demonstrated then? Okay. So the electrodes should be closer. Okay, so in this lab, they have taken the electrodes of about 6 to 8 inches, and however, the gap is taken as low. Okay, and in this experiment, they have demonstrated that how the breakdown strength, means the breakdown voltage, varies with the separation between the electrodes. So first they have taken one gap and find the breakdown of that gaseous, and in this experiment the gaseous particles are air. Okay, as there is no other materials, it means there will be definitely a gas particle between these electrodes, the air particle, sorry. So the air is having a good dielectric strength, and it is free of cost. So air can be used as a good dielectric material. Okay. Other gases as a dielectric are SF6, nitrogen, carbon dioxide, etc. Okay. So let's start from the gaseous breakdown in gaseous high voltage testing experiment. Okay. Okay. So um, first we will measure the gap length between the electrodes, and we will tabulate it. Okay. So um, we can see that a breakdown was occurred for the gaseous particle in the form of spark and the discharge, and the breakdown voltage is equal to 11.25 kilovolt. Okay, now add the gap distance 1 centimeter. So what would happen for the 1 centimeter gap? Adjusting the gap between the electrodes by proper measurement, not for assumption, but a proper measurement, and we will observe the breakdown of gases in the form of a discharge. This is a 1 centimeter gap length. As we have discussed that in the breakdown strength of air is 121 kilovolt per centimeter. So yes, 21 kilovolt, and the gap was 1 centimeter. So that's quite according to the theoretical data as we have studied in the books. So this was a practical demonstration for the breakdown of the air for the 1 centimeter gap length, which is equal to 21 kilovolt. Okay. Now at gap distance 1.5 centimeter. So means the gaseous particles are added by increasing the gap distance between the electrode. Indirectly means we have added the more gaseous particles between the electrodes. So as the more gaseous particles will be added, so the breakdown strength will be more strengthened, and we will have a high value for the breakdown voltage. So let's demonstrate it practically. Okay, now the distance has been increased, and now the gap between the electrode is 1.5 centimeter. Okay, now the breakdown voltage obtained is 32 kV. As I have already told you that by increasing the number of particles, the breakdown voltage will be increased. Okay, and you can see that this experiment is performed in a net and offenses for the sake of the safety. So a high safety is required for the high voltage testing experiments. Okay. Okay. Now switch to the second experiment, that is the insulation testing of transformer oil. Okay. The insulation testing of the transformer oil. Insulation test of the transformer oil means the liquid breakdown test. Okay. So uh, we have to fill this table for the for the transformer oil testing. Okay. The first operation, the breakdown voltage. And then for the second operation, the same the same liquid will be used for the second operation, for the second breakdown. So we will observe that for the fresh air, for the fresh transformer oil, the breakdown voltage will be high. But once a breakdown is occurred in that particular sample, so for the second operation of that sample, then the breakdown voltage will be reduced because now the liquid is no more the fresh. It has been used, a discharge has been occurred, and a carbonization has been occurred. So uh, the for the second operation, the breakdown voltage will definitely be reduced. So let's have a look. Experimental setup. Okay, this is spherical electrodes. Okay, spherical electrodes, and this is a vessel. Okay, a container where the oil will be poured, and the oil will be poured in such a way that these electrodes must be dipped in that oil, and we should carefully pour the transformer oil in that sample so that no bubble is occurred while pouring the liquid in that container. Okay, because we have studied that bubble is very much destructive for the breakdown strength of the liquid dielectric. Okay, these electrodes are movable. Okay, both of these electrodes are movable, the positive and the negative. Okay, we are pouring the transformer oil in such a level that the electrodes should be dipped, and you can see that how carefully the transformer is pouring very close to the container so that no bubble is occurred, because the bubble can reduce the breakdown strength of the liquid dielectric. The bubble acts as a contaminant, the impurity for the liquid dielectric. So okay, now this is the positive terminal for that vessel, and the black is the ground. Okay, the red one is the positive, the phase. Okay, and the black will be ground, neutral. Okay, look, and that will be attached over here, the ground. We will cover that vessel, and then experiment will be performed. Okay, and you will see a discharge when the breakdown will occur. So a discharge is actually the indication of the breakdown of the liquid in the gaseous and in the liquid as well. Okay, so slowly increase the voltage supplied to that uh, liquid dielectric, and we will increase the voltage until a breakdown is occurred. So we will slowly increase the applied voltage. Okay, okay. Now a flash shower has been occurred, a discharge has occurred. This is actually the indication of the breakdown of the liquid. Okay, and you will see that blackish layer will be observed over the surface of the liquid dielectric. That is because of this discharge. And the blackish color is actually the carbon, because the liquid, the transformer oil is made up of is actually a hydrocarbon. Okay, so means that blackish color will be actually carbon. Okay, so look, this is a blackish layer, and that is because of this breakdown. Okay, and now the fresh is no more, the liquid is no more the fresh. Okay, it has been used, and one breakdown has been occurred, and the breakdown voltage for the first operation was 22.69, means 23 kilovolt. Okay, now, and this is for 1 centimeter. Now the second operation, look at the color. The color is black. It is also indicating indication of that the breakdown will be occur at low voltage. as compared to the first operation. The viscosity, the color, these are the surface tension, these are the indication of mm, mm, the breakdown of the liquid dielectric. Okay, so now for the second operation of this same sample, look, the breakdown is now occurred at 10.17, means half of, almost, or lower than the half of the breakdown value of the first operation. Okay, for the same uh, gap length between the electrodes, and that is because of the oil strength has been weakened because of the first operation, the first discharge. Okay, so that was all about the transformer oil testing, and now uh, I will demonstrate. I will show you a video clip of the plasma. Okay, we have studied the plasma in our class, and we have studied that what is plasma. Plasma is actually the ionized particles. Okay, and we have also studied two types of the plasma. The one is the neutral plasma, and the other is the non-neutral plasma. Neutral plasma doesn't mean that these are the neutral particles. No, these are actually the ionized particles, but having the same number of positive and negative ionized particles. That is why it is called neutral plasma. But in case of non-neutral plasma, we have either the positive ionized particle or the negative ionized particle. So we have one species of the ionized particle. That is why it is called non-neutral plasma. Okay. So how ionization is occurred, we have already studied these, and so briefly, for example, we have the helium gaseous atom. It is a neutral gaseous atom. So electron will hit that neutral atom if the kinetic energy of this incident electron is greater than the ionization potential of this helium atom. So electron will be ejected, and the some of the energy will be utilized in the form of mm, this discharge. Okay, so this is actually the plasma. The the color indicates that the plasma has been occurred. Okay, so different gases have different plasma colors. So they have considered four different gases. The argon, the color for the argon is like that, and the helium. Okay, this is the helium, and water. Water means the water vapors, not in the liquid form, but in the gaseous form. So we have the water color. The plasma for the water vapors are this. Okay, and the carbon dioxide is this one. So you can see we have increasing the applied voltage. Now in this case, the incident electrons are not used, but the voltage is used to cause the ionization of these gases. Okay, different external agencies can be used to ionize the gaseous particles. Means we can use the electric voltage, we can use the sound energy, the kinetic energy, the collision, the vibration, the light energy, the heat energy. So the example for the light is the solar panels. The, when the light is fall on the solar panel, it ejects the electron from the solar panel. Okay, so different plasma have different colors for the different gaseous particles. Okay, so that was all about the plasma, and now we will switch to the arc. Okay, we have studied the arc. So what is actually the arc? Actually, the arc is, so Yes, this is actually the arc. Okay, look, isolator is isolate. This actually the isolator, and it is disconnected on the load condition. That is the wrong way. Okay, we have to disconnect the isolator on the no load condition, in the off condition. And here the isolator is disconnected on the load condition. So what actually occur? The air between these two contacts is ionized. So these charges, these are actually ionized gaseous particles, ionized air. So now this become conductive. In the normal condition, the air acts as a dielectric, but if the electric field or the electric voltage is such that it can overcome the ionization potential of the gas, then it will appear as a discharge. Okay, so now the breakdown of the air has been occurred in the form of this arc. Look, these are the um, views for the breakdown of gases. Short circuit. Okay, now the solid insulators are on fire, means discharges occur, and means the breakdown of solid insulator has been occurred. Okay, it cannot perform the insulation now. Rather, it allow the current to flow through it. So the breakdown of the solid is occurred. This is the view of the transmission line. Look, and the air is ionized, and it appears as uh, the discharge. Okay, now the trees are in contact with transmission line and become short circuited. Look, this is the arc. Okay, and a blast is occurred. So that was all about these few experiments. We have I have um, collected and merged few of the video clips regarding the high voltage, so that a demonstration is occurred for new people. Okay, so thank you.